Hello all, this is a continuation video of the unit number 1, that is a CAD for additive manufacturing. Uh, the benefits of the CAD additive manufacturing and the conventional manufacturing, you can see here the design is optimized. So that is what the conventional and the optimized design. You can see here, the left hand side, you can see traditional design and the optimized design. So here the weight of the product is 155 gram, and here the additive manufactured product, that is on the right hand side, you can see that is a titanium buckle designed by the using additive manufacturing is just 70 grams. So this is a simple product. You can see the difference between the conventional and the additive manufacturing. So the weight should be reduced on a like for like basis with saving the project. For here for an Airbus, there are 380 Airbus 380 with all economy seating 853 seats, right? This would mean a reduction of 72 kg. So this is what the precision achieved in the additive manufacturing when compared to the other manufacturing process. Then the you can see the project partners are Plunkett Associates, Crucible Industrial Design, EOS, 3T PRD, Simpleware, Delcam, University of Exeter. So over the airplane's lifetime, 3.3 million liters of fuel or approximate euro 2 meter could be saved. Right, 2 million can be saved. Assuming a saving of 45,000 liters per kg and airplane lifetime. So this is what the benefit of this above case. So the weight reduction. So this is how the additive manufacturing plays a major role nowadays in the engineering industries. So coming to the material classification, there are different kinds of materials processed in the additive manufacturing techniques. The main materials are listed. One is the polymer, next is the metal, ceramics and composites. Polymer, you can see here, there are different types of polymers. One is the ABS, acrylobutadiene styrene polymer. Next is the acrylics, cellulose, nylon, polycarbonate, polyethylene, polypropylene, polyvinyl chloride, then thermoplastic polyester. So these are the polymers that can be used in the additive manufacturing process. That is the 3D printing machines. So other than these metals, you can see titanium can be used, aluminum can be used. Nowadays, most of the ferrous metals can be used in the process. Then ceramics used, and the composite is a combination of two or more materials, that is it can be a metallic or non-metallic, that can be used as a composite material. So these are the materials that can be processed in this process. This is an example of the standard tessellated file or standard triangular file. You can see here the coordinates of the element are specified in the according to the coordinates x, y and z coordinates. So here the advantages of the STL file format that is used in the additive manufacturing technique. So the CAD model is created using any software. That CAD model is then converted into the STL file and then it is fed into the machine. So this is the primary process in the additive manufacturing techniques, right? So the solid, liquid, powder based process. What can be done is, one is the so 3D modeling object is created, 3D model is created, then the file is converted into STL file, that is standard tested language file, and then the machine preliminary work, that is the filling material and then setting up the bed size and preparatory work is done, and then the machine starts printing. So one of the advantages of this STL file format is it is a simple representation of the CAD data, and the standard most of the CAD and rapid prototype system uses this file format only, and then it can provide accurate file for transferring certain shapes. So that is very much important because the design should be read by the machine. And some disadvantages of this file format is that you can see here larger than original CAD file. Yes, sometimes the file size may be larger than the CAD file, and then the geometry flaws. In the there are some geometry flaws. That is one of the geometry flaw you can see in the bottom of the slide. That is the machine should print one, two, three, four triangles, but the machine prints it is a simple rectangles like that. So this is what the geometry flaw, that is the clearance is not given by or printed by the machine. So the subsequent slicing, yes, that is what the difficulty in this file format. So this is what the advantage and disadvantage of the file formats. Also the problems, you can see the gap, as I told in the previous slide, the gap that is missing in the facets, then it degenerates the facet, that is edges are pulling in, the edges are not formed properly. Then overlapping facets, so the one image is overlapped and the another one layer is overlapped or one boundary is overlapped. So that is a main issue. And the topology condition, non-manifold topology condition also leading to a major issue in the file formats. So these are some of the slides which are indicating the issues or the errors in the STL file formats. So the repairing can be done internally by using a software. Slicer is one of the software which generates the STL file from the CAD. So there are technologies that are involved in getting the good product. The technology is updated nowadays. So this is another chart which shows the different types of process, that is solid, liquid, and powder based process, which I discussed previously. Sintering laser based process uses powder materials, and liquid materials we can see in stereolithography. There the photosensitive or photosensitive resins are used, and the light sensitive resin is always called as, and the laser scans the layer to solidify the layers. Then the solid based, you can see here, laminator object manufacturing, foil polymerization, etc. etc. So these are the classification of layer by layer manufacturing process. So the 2D and 3D modeling difference we will see in the next class. Thank you.